In this video, we'll be covering the Active Directory method for single sign-on, or SSO. The first item will be to cover what SSO actually is. Then we will move into how to configure it to work with Active Directory. And this involves setting up the software on the Active Directory server and configuring those components. And then lastly, we'll round it out with some troubleshooting. I want to point out that there are some known security issues with the AD SSO software. Check these advisories for workarounds. Once these are addressed, the configuration of the AD SSO feature will change, and it is unlikely that there will be backward compatibility. The Radius SSO option does not require software, so it is not impacted by these vulnerabilities. No workarounds required. Plus, Radius SSO works with Active Directory. Please check out our existing video tutorial and documentation on this feature. So what is SSO? It's a seamless way to authenticate users. This means that we're able to collect this information automatically and send it to the firebox. There is no manual work the users have to do. They don't have to go to a web page. They don't need to log into any particular software. Everything is done in the background, regardless of which component you decide to install. This can be useful because organizations may simply want to look at what users are doing on the network, and that way they can see log data or report data based on that user activity. But you may take it one step further and actually provide different levels of access for your users and groups. To achieve this, you would need to configure your firewall policies to have different users or groups in the from field and create a list of tiered access policies on your firebox. That would be covered in a separate video or using the documentation. We'll just be covering the SSO configuration in this video. How does Active Directory work with our SSO components? Well, you would install a particular piece of software known as the SSO agent, kind of the central point for everything. And when the firebox detects an unknown user, so an IP address that has no username associated with it, it will reach out to the SSO agent and ask it to figure out who is logged in on that computer. The agent can then reach out to one of the other SSO components, such as the client, the event log monitor, or the exchange monitor. Once those components return the information, the SSO agent will forward that back to the firebox, and the user session will be created automatically. When it comes to the different platforms that will work with this process, Windows works with any of the components, Mac OS will work with the client or the exchange monitor, and any other platforms will have limited support using only the exchange monitor. If you need other platforms to be supported, you can use the Radius SSO option. So what does this authentication flow look like? Well, without going into too much detail about the different software components yet, first we begin with the client request for internet access. It will send that traffic to the firebox. The firebox then realizes that it needs to retrieve the user information, so then it will ask the SSO agent. The SSO agent then, via some mechanism, asks the client devices and then retrieves that information and passes it back to the firebox. When it comes to those software components that the SSO agent communicates with, there are 3 different options you have available. Out of everything listed on this slide, the agent, the event log monitor, or ELM, and the exchange monitor, all 3 of these components can do a client-less method of operation. However, the SSO client is the recommended option for the most reliable Active Directory single sign-on experience. I will be focusing on using the SSO client in this video, as it is the easiest option to set up. When it comes to deploying the SSO client, you only need a single Active Directory group policy. When you create this group policy, ensure that the source path for the file is on a network share that is accessible to all of the computers on the network. This is the only Active Directory group policy you'll need for the client, which is why it's the simplest option. If you decide to go with the SSO event log monitor, you would need to create these 3 different group policies and ensure that they are applied to all computers on the network. Otherwise, the event log monitor service will fail to retrieve user information. When it comes to installing the SSO agent software, you can also choose to install the event log monitor. This is an optional component and it is something that you would need to install on other domains if you had multiple domains within your network. As far as the single sign-on agent, you can install that on multiple domain controllers as well for redundancy purposes. In my example, I will install both just so I can show how the event log monitor is configured to use as a backup for the SSO client. So here you need to input a username in down-level format. This is the account that will be used to launch the SSO agent service, as well as the event log monitor if you installed that. This user must have permissions to launch services on the Active Directory domain controller. It is recommended to have a dedicated service account for this purpose, such as the one I have configured here. And that's because if you try to use a personal account, whenever you change your passphrase, the services will stop working. So if you create a dedicated account with a passphrase that's complex and never expires, then it will ensure that the SSO agent services run as expected without interruption. Once the installation is complete, it will start the services automatically, and then you are able to launch the SSO agent. Here I've launched the SSO agent configuration utility. The default credentials are admin and read-write, just like on the Firebox. Once you are logged in, it's recommended to go to Edit, User Management, and update the passphrase for the admin that you log in with. Once you've done that, it's time to configure a domain here. So go to Edit, Add Domain, and then fill out the necessary information. It is recommended to use the loopback IP address here on the primary domain controller where I have the SSO agent installed, because if the domain controller has multiple NICs or it goes through an IP address change, then the SSO software would be unaffected. As far as inputting the username, I personally like to use the UPN format, but you simply have to choose whichever one you prefer to use when inputting the user information. Once you've done that, go ahead and click OK. That gives us the base configuration for the domain. The next thing we need to do is go to Edit, SSO Agent Contact Settings. This is where we set up the other components that the SSO agent will talk to in order to retrieve user and group information from the host devices. In this list at the top, you enable and disable whichever options you want to use, and then you can also set the priority. Because I prefer to use the SSO client due to the reliability, I've set that to be the primary SSO method, with the event log monitor and exchange monitor being backup methods. Down here, you must also configure your domain and the IP address of the domain controller you would need to query when using the event log monitor or the exchange monitor. Once you have this set up, go ahead and click OK. And that's it for configuring the SSO agent software. I have Policy Manager open here, and in order to get to the SSO settings, go to Setup, Authentication, Single Sign-On. I'm using the Active Directory option in this example, so I'll go ahead and enable that. And the first step is to configure the SSO agent that the Firebox will talk to. So this will be the IP address of the domain controller where the SSO agent is installed. Once you've filled this out, click OK, and then you can add more SSO agents if you have multiple DCs in the network and you want some redundancy. If you just have one, no problem. The other piece you must configure is the SSO exceptions list. This one is very important because this will reduce the burden on the SSO software and give you faster results. So what does this list do? Well, it tells the Firebox not to ask the agent who is logged in to the IPs and subnets you've listed here. The reason this is important is because if you have non-domain devices, such as networking equipment like routers and switches and Wi-Fi access points, or if you have devices like printers or copy machines or anything else that gets an IP address on the network, and most importantly, if you have guest networks with a bunch of users logging in there, of course, none of them are domain machines, so all of these devices must be put on the exceptions list. do not leave this list blank. This can cause the SSO software to get stuck in a situation where it just keeps asking those devices repeatedly for user information, which can create some problems. Go ahead and click Add and put in some examples here. So this is a simple example of a guest network, and then I can also go ahead and add another device, just like that. So fill out this list with everything on your network that you know is not a domain computer, or you just simply don't want it to participate in Active Directory SSO. You might even consider putting other servers and things on this list as well. The settings down here at the bottom are related to having multiple SSO agents, and this is how it's able to detect when an SSO agent has gone offline. So the interval is how often it checks in with the other agents, and the timeout is how long it waits before considering that agent to be in a failed state and then moving over to another agent. And lastly, we have the checkbox to allow single sign-on through BOVPNs. So if you had clients at a remote site that needed to authenticate through the SSO agent at your main site, you can enable this, but it is highly recommended to only use this option with the SSO client. Otherwise, you may experience some BOVPN throughput issues. I'll go ahead and click OK here, and that is it for the SSO configuration on the Firebox. When it comes to troubleshooting SSO, one of the first things to check is on the Windows Services list. You can see here that I have the event log monitor and the authentication gateway, which is the SSO agent, and both services are set to start up automatically, and they're both currently running. If for whatever reason either of these services is stopped, then SSO will fail. The other thing that may happen is if you have changed the account or the passphrase for the account. If you open up the service and go to the Logon tab, this is where the account information is set. This is what I had input during the installation of the SSO agent. So go ahead and update the account and passphrase as necessary if they ever change. In some cases, you may even need to restart the services here in case something is hung. Beyond the service issues, you may even have some network communication issues. So when it comes to the ports that the Firebox and SSO components are using to communicate, all of the ports listed in this diagram are TCP ports. We'll begin here with port 4114. This is used for the Firebox to query the SSO agent installed on your Active Directory server. If this port is not the issue, then you can move along down the chain. So with the SSO agent installed on the AD server, it has 4 different methods of communication. As mentioned earlier, there are 3 optional components. The SSO client here is the primary method, and that is using TCP 4116, which the client would open during the installation. And this client will only send communication to the agent when there is a logon or logoff event occurring, and this includes local logon as well as RDP logons. So the communication is very efficient. The agent can also query the client at any time to find the current status, but throughout the day there's just going to be minimal communication between these two. When it comes to method number 2, that would be going through the event log monitor, so the agent will query that. If they're installed on the same server, then the port doesn't matter. But if you install this somewhere else, it'll use 4135. The way ELM works is that it will query the PCs directly on port 445, and it does this roughly every 5 seconds, so it can check the Windows event logs to see what the most recent events are. Because it has to query these machines so often, that's where you can run into some problems if you did not properly fill out the SSO exceptions list, or you are trying to use SSO over a BOVPN with ELM. This is why we recommend using the SSO client. Furthermore, the ELM process only looks for specific event logs, so if there's any events that happen outside of those logs, then it will be totally unaware of what's happening on that machine. The third process is for the Exchange monitor, so it will query that on port 4136, and the Exchange monitor looks at the IIS authentication logs on the Exchange server to determine what user is logged in on whatever device is connecting to get its email. This is why it works with any type of device that you have on your network, whereas something like ELM only works with Windows devices. The last method of SSO is kind of a failover method. This is a last resort. If the SSO agent cannot communicate to any of the other components, then it will try to do a direct query on port 445 to the computers. Similar to ELM, however, the SSO agent will not be using the event logs. It will use a Windows API call to figure out the current user, but this API call does not always return consistent results. So your best bet is to get one of the other methods working reliably and not rely on this failover method. When it comes to the different event logs that the event log monitor will use, primarily you're going to be looking for event IDs 4624 and 4634. For a complete list of the event IDs that ELM uses, please reference the WatchGuard help. The important thing here is to take a look at the date and time of these events. If the computer is not recording event logs properly, or you are not seeing the expected events happening in the logs, this is why the ELM component may report incorrect user information for any particular computer. In order to collect diagnostic log data from the SSO components, you first need to connect to the SSO agent using Telnet on port 4114. You'll be greeted with this screen, and in order to log in, you type the word login, and then you type the credentials that you use to log into the SSO agent. If you change the credentials after you first launch the SSO agent configuration tool, those will be the credentials you use to log in here. Once you log in, you can type the help command to see the different options that are available. And the one you're looking for is the command here named setDebugOn. Once you run this command, you will see that it is writing logs to your user's temporary directory. These logs will also likely be present in the installation directory of all the different SSO components, because the SSO agent tells the other components to enable their debug logs as well. Once this is enabled, go ahead and run some tests on a particular machine with the user. Once the test is complete, go ahead and grab the logs or use the download diagnostic option in the SSO agent configuration tool. When you are done collecting the logs, use the setDebugOff command and then type quit to exit this. After you've used the Telnet diagnostic to enable the debug logging, you can use the SSO agent configuration tool to download those diagnostic files. You can do that by going to File, Diagnostic Log Files, and then selecting the components that are relevant. In the case of the client, you input the IP address of the client machine that you would like to run the diagnostics on. Once you click download, it will grab all of the log files and put them into a zip file that you can share with our support team or investigate on your own. The Firebox typically also receives some of these error messages from the SSO agent, and it will display them in the traffic monitor. When it comes to deciphering the different SSO log messages, you can look at the documentation at this Troubleshoot Active Directory SSO topic and scroll down right here to the common error messages. If you expand this, you'll see samples of the different types of error messages that will show up and an explanation of why these errors may be occurring. So to wrap things up here, the SSO client is the best option because it's very easy to deploy. You only need the single group policy, and the communication is efficient. It doesn't need to constantly query all of the machines throughout the network every 5 seconds. Furthermore, it does work on both Windows and Mac machines. It's recommended to use a dedicated account for the SSO functions, and it doesn't matter whether this is an admin or a regular user, but if you decide to go with a regular user, check out the documentation for the requirements. And of course, make sure to fill out the SSO exceptions list. Don't leave it empty. There's at least a couple of devices on your network that are not domain machines, so please fill those out so that the SSO software doesn't constantly query them for user information. If you are using the 12.5.4 or newer SSO software, the Firebox must also be on 12.5.4 or higher. This is a new requirement due to upgraded encryption in the software. Whereas normally you can mix and match the SSO component versions as well as the firmware. And lastly, If SSO is failing, check that the services are running on the server, verify all the communication between the components, and gather the necessary logs. That way our support team can help you out. For more information on Active Directory single sign-on, please use the WatchGuard technical search.